Okay, question 20. The diagram shows a square-based pyramid with base PQRS and vertex O. All the edges of the pyramid are of length 20 meters. Find the shortest distance in meters along the outer surface of the pyramid from P to the midpoint of OR. Okay, so midpoint of OR is somewhere here, right? So somewhere here, yes. Okay, so the key thing is you can only go along the outer surface, yeah? So you can't travel, midair, right? You can't just go from P straight to, the points, yeah? You have to go along the surfaces. Okay, so intuitively, what routes are good candidates? What routes are possible? So we either, I think there are two possibilities. Yeah? You either go P to SR, right? Hit SR somewhere and then go up like this, right? So like this and then like this. Or what else could you do? You can go the other way, which is, somehow going to OS and then going to that point. Right. Okay, so these are two most plausible routes. Yeah? If you take other routes, then it definitely takes longer, just by intuition, right? Okay, so then now we're going to figure out, well, how to calculate the distances of the green routes or the blue routes. Right? And it's very hard to calculate distances on 3D surfaces. Yeah. So the classic trick is to do what? To draw a 2D version of this. Yeah? To draw a 2D version of this is much easier. So for example, the green route involves what? The green route involves the square PQRS, of course. It also involves the triangle ORS, right? So let me draw it. So the R should have been here, sorry. And the S should have been here. So let me draw it like this. Yeah, the O is here. So the root is what? So the midpoint of OR is somewhere here. So then the root, of course, you will take a straight line distance, right? There's no way that you don't take a straight line. So it should be somewhere here, right? From P to the midpoint of OR, that's a straight line distance. Okay, how do I calculate the distance of that? Lots of ways, right? But what I'm going to do is that I'm going to force some coordinate axes on here. I think that's the easiest way to do it. Yeah, just force some coordinate axes on here. Okay, so what are the coordinates of P? Well, the side length is 20 meters, right? So the coordinates of P is, what is it? I scrolled up, for some reason. So this is negative 10, 10. Yeah, because the side length is 20. Good. Okay, so what are the coordinates of R, for example? R is 10, negative 10, right? So what's the coordinates of O? So O is definitely 0 something, but what is the something? So we're going to figure out the height of the triangle. And we know that is the equilateral triangle, this guy, the height here. We know it's the equilateral triangle, right? And the side length is 20, so you could do Pythagoras, right? If you imagine this is 20, 20, 20, then this guy must be 10 root 3, right? Very standard calculation. I'm not going to do it. So the coordinates are negative 10 minus 10 root 3. Yeah, for O. Good. So midpoint of OR, so you can use the midpoint formula or something. This becomes 5, and then negative 10 minus 5 root 3. Yeah? Good. So now we take the distance of that. So what is the distance? So let me give myself some space. So I'm going to get rid of the triangle. So the distance, you take a Pythagoras, yeah, just distance formula basically. So the distance is the change in x, which is 15, plus the change in y, which is 20 plus 5 root 3. So these two things squared and then square rooted, yeah, and then we simplify. So this is 225 plus 400 plus 200 root 3 plus 75. So this is 700 plus 200 root 3, and you can take the 10 out, right? So this becomes 10 square root 7 plus 2 root 3. Okay, so it seems like none of the answers have that, right? So it seems like this might be the longer route then. Yeah, so we're going to check the blue route as well. Yeah, we're going to check the blue route as well then. Okay, so let's check the blue routes. I'm going to erase the screen and I'm going to be back, okay? So I'm going to pause the recording for a bit. Okay, so now let's think about the blue route. So the blue route involves two triangles. Yeah? It involves OPS and it also involves ORS. Yeah? So again, 2D version of this. So OS and then P is somewhere here. Now remember the equilateral triangles. Yeah, the equilateral triangles. So this is R. Yeah? So I'm going to go from P to midpoint of OR. So what's the distance there? Again, we take the straight line distance because that's shortest, and I'm going to force a coordinate system on here again. Okay, so what's the coordinates of P? Well, this will be, so I did a calculation just now, right? It's 10 root 3, the height of the triangle. So negative 10 root 3, 0. Okay, what's the coordinates of R? That is 10 root 3, 0. What's the coordinates of O? That is 10, 0. I meant 0, 10, of course. So what's the midpoint of OR? 5 root 3, 5. Yeah, good. So we now take the distance from P to that midpoint. So same logic, change in X plus change in Y. So change in X squared, that is 15 square root of 3 all squared. The change in Y is 5, so plus 5 squared. So let's see what that gives us. So this is 225 times 3, that is 775. Wait, am I doing this correctly? 675, sorry. What am I doing? 675, yeah? And then plus 5 squared, that's 25, yeah? So this is square root of 700, which is 10 root 7, right? So just now, the answer was what? Just now it was 10 times square root of 7 plus 2 root 3, right? Just now you have that extra 2 root 3 in the square root. So the green root just now is definitely bigger, yeah? So that's why the blue root is preferred. It's shorter, right? 10 root 7 is much smaller than what we just found, yeah? So final answer will be D, 10 root 7.